So now in this video we have a 555 timer, and by the way I'm using 5 volts, but we could go up to 9 volts because I have a higher value resistor protecting the red LED than I normally do. But in any case, we got just one button here. Right now the output is low. I press the button, now the output is high. So I should wait a little while, probably about 5 seconds or so. Now I can press the same button again and the output will be low if we don't get a glitch there. So there we go. I think could be switch bounce. Maybe the switch isn't in the board as good as it could be. But in any case, there you can see that we can set the output high right there, or we can set the output low with just one button instead of having to use 2. So now looking at the schematic here, whether the output is high or whether it is low right there, when the switch is open, you can see pin 2 and pin 6 right there have a voltage divider across them. That'll get them half of the supply voltage, which means neither one of them is responding. So it just leaves the output in either high or low state. If the output is high right there, then the capacitor is charging through the resistors. If the output is low, then pin 7 is also connected to ground right there. The capacitor is discharging right there. So if you wait long enough, the capacitor will become either fully charged or else it will be fully discharged. And as a reminder, this is not connected there. For those that really like it, I put dots where everything is connected. But here is a jump. That is not connected to everything else. Now, we have one scenario. Let's say the output is high right now, as close to 5 volts as you can get. That means that the capacitor is also fully charged. When we press the button right there, then we will get a connection to the capacitor where the 2 inputs are right there. When pin 6 sees that you have higher than 2/3 of the supply voltage at the capacitor, then what it does, it sets the output low. The blue LED lights up, as well as whatever current goes to that resistor goes to ground, and the capacitor starts discharging right there. So press that button and release it before the voltage changes kick in. And so then we have a low output at that point. The capacitor is discharging. Capacitor is going to fully discharge at some point. But these 2 inputs don't see, they see like half the supply voltage, they don't do anything. So it discharges, and later on we will press the switch. Then pin 2 will see less than half, or less than 1/3 I mean, of the supply voltage. And when pin 2 sees less than half, or I'm sorry, 1/3 of the supply voltage, then it sets the output high again. Pin 7 stops discharging at that time, and the capacitor starts charging. So we are taking advantage of the capacitor wanting to do what the output is doing, whereas the inputs want to change the output when the capacitor is like the output. And here is a close-up of the circuit. These 4 resistors are 10K resistors, and I accidentally gave false signal. There you can see we got 10K going to pin 2, a jumper going to pin 6, and then from the positive supply there, a jumper to pin 6, and then we have a 10K resistor going to the negative supply. So that's going to hold the voltage at the inputs there to half of the supply voltage unless we overcome it. Now we have a 10K resistor up here that going positive supply to pin 7, and then a 10K resistor coming over to where the capacitor is. When you're not pressing the switch, it's an open circuit there. So it's just coming to the capacitor and the bottom of the switch. And again, I sent false signals somehow. Now, when we close the switch, there we go, then the capacitor connects to pin 6 and pin 7 right there. And so these 2 voltage dividers there are going to quickly kind of suck it towards half of the supply voltage. But also, this is either going to start discharging or charging, depending on what we had earlier. So right now the capacitor is charging. The output is high through the 2 resistors. When I press the button, it gets to about half the supply voltage. I think that's switch bounce. Maybe, nope, okay, it's probably just yeah, this can more easily discharge. That makes sense because you got 2 resistors to charge it. So it makes sense that it will want the capacitor to discharge rapidly if you hold the button too long. So that's a good thing to keep in mind. Got to press the button switch for this particular, press the button quick for this particular circuit. So yeah, in any case, there you can see the capacitor can charge until we press the button. It sees the signal and then starts discharging. And pin 6, when it's above 2/3 supply voltage, it sets the output low, as you can see there. And then pin 2, when it sees less than 1/3 of the supply voltage, it sets the output high. So to improve this circuit, I think I would probably use maybe 100K resistors for charging and discharging the capacitor, because when we press the button, I'd like to maintain like half of the supply voltage across the capacitor until I release it. And I think since I'm using such equal value resistors, it's very easy to discharge the capacitor quickly, even when the switch is closed, and be able to suck down the voltage to less than 1/3 of the supply voltage, since it can discharge more quickly than charge. But for now, this is the circuit we have. I made this a while ago as a demonstration circuit. It did its job, where you can see that just a quick press of the button will change the output, just a single button, instead of having to use 2. You have one set the output high and the other one set the output low. So hope you enjoy. Make sure you check out one of the other videos I post on the screen, and check out the links down below. They all help out a lot. I'll see ya in the next video.